Oh, good. So, good evening, all of you. Today, our topic is electromagnetic waves. Today, our topic is electromagnetic waves. Yeah, good evening, all of you. Give the heading electromagnetic wave. This is the last chapter of first volume. This is the last chapter of first volume. So my target is that before Onam exam, we should finish first volume. I hope we can do that. Before Onam exam, we should finish the first volume. What is the chapter name? Electromagnetic waves. Electromagnetic waves. This is the chapter name. Electromagnetic waves. Now, in this chapter, first of all, we should know what is electromagnetic spectrum. Electromagnetic spectrum. Orderly arrangement of electromagnetic waves according to either frequency or wavelength is called electromagnetic spectrum. Electromagnetic spectrum. Orderly arrangement of electromagnetic waves according to either frequency or wavelength is called electromagnetic spectrum. Electromagnetic spectrum in the descending order of wavelength is order of frequency is electromagnetic spectrum in the descending order of frequency is first one gamma, second one X-ray, third one ultraviolet, fourth one visible, fifth one infrared, and the sixth one microwave, and the seventh one radio waves. Now remember, inside visible light we have VIBGY or violet indigo, blue, green, yellow, orange, red. I used to remember this with a code. Onam exam state syllabus start chedu sir. Yeah, okay. I think we have done our sure shot for the first chapter. Short note, exam point of view, video is uploaded already. It is easy to remember in this way. XI-XII Wimmer. What is visible light? Inside visible light we have what? VIBGY. It's easy to remember. XI-XII Wimmer. Remember, gamma rays have highest frequency. That is lowest wavelength. Highest frequency nu, that is lowest wavelength lambda. Radio waves have lowest frequency nu, that is highest wavelength lambda. Now remember, all electromagnetic waves travels with speed of light in vacuum. Speed of light in vacuum. All electromagnetic waves travels with the speed of light in vacuum. So, question, what is the ratio of speed of X-ray to speed of gamma ray in vacuum? What is the ratio of speed of X-ray to speed of gamma ray in vacuum? What is the ratio of speed of X-ray to speed of gamma ray in vacuum? This is the question. So what is the ratio? All electromagnetic wave travels with what? Speed of light. So what will be the ratio? X-ray to gamma ray. Gamma denoted by this. X-ray speed is what? 3 into 10 raised to 8. Gamma ray speed is also what? 3 into 10 raised to 8. So what is the answer? 1:1. What is the answer? 1:1. So please note down this screen. Within 2, maximum 3 classes, we will be finishing this topic. Please note it down. Please note it down, all of you. Please note it down. Others, good evening. Ismaya, Saranya, Adira, Anusri, Anjal, Alanchand, all of you, good evening. Done, right? All of you noted? All of you finished? What about others? Agash, finish. Is it done? Yeah, okay. Let's continue. Next, relation between mu 0, epsilon 0 and C. We know that mu equal to mu 0 mu r. Mu 0 is what? Permeability of free space, means how effectively a medium permits magnetic field. Mu 0 equal to 4 pi into 10 raised to minus 7 Tesla meter per ampere. Epsilon 0 is equal to permittivity of free space. Epsilon 0 is equal to 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square, means how effectively a medium permits electric field, that is epsilon 0. How effectively a medium permits magnetic field, that is permeability, and this is permittivity. Simply mu means what? Permeability. Simply epsilon means what? Permittivity. Now remember, I'm multiplying mu 0 with epsilon 0. That means mu 0 is what? 4 pi into 10 raised to minus 7. Mu 0 epsilon 0 can be written as mu 0 by 4 pi into 4 pi epsilon naught. If you cancel 4 pi, you will get the same equation only. So I'm just doing a small trick. What is mu 0? 4 pi into 10 raised to minus 7. I am multiplying mu 0 epsilon, multiplying divided by 4 pi. So 4 pi into 10 raised to minus 7 divided by 4 pi into, I know that 1 by 4 pi epsilon naught is what? 1 by 4 pi epsilon naught is 9 into 10 raised to 9. What is that? Newton meter square per Coulomb square. So 4 pi epsilon naught by 1 is what? 1 by 9 into 10 raised to 9. So here I am seeing 4 pi epsilon naught by 1. So I am writing 1 by 9 into 10 raised to 9. So 4 pi gets cancelled. I am getting the equation mu 0 epsilon 0 is equal to 10 raised to minus 7 comes to denominator, it becomes 10 raised to plus 7 divided by 1 by 9 into 10 raised to 9. So mu 0 epsilon 0 is equal to 1 by 9 into 10 raised to 16. So mu 0 epsilon 0 is equal to 1 by 3 into 10 to the power 8 the square. So mu 0 epsilon 0 is equal to 1 by c square. So c square equal to what? 1 by mu 0 epsilon 0. So c is equal to what? 1 by root mu 0 epsilon 0. Please remember this equation. What is 3 into 10 raised to 8? 3 into 10 raised to 8 is equal to what? C, that is equal to speed of light. So please remember this equation. Any doubt? Any doubt? See, this is the case when we are discussing about air or vacuum. For air or vacuum, mu r equal to epsilon r equal to 1. For all other media, what should be your formula? V is equal to 1 by root mu 0 mu r into epsilon 0 epsilon r. See, why I am not writing mu r and epsilon r here? Here I am assuming that in air or vacuum, mu r equal to epsilon r equal to 1. So that is the reason I am not writing mu r and epsilon r here. Because even if you write that, there is no change. Because its value is what? 1. And the speed of light is what? 3 into 10 raised to 8. Now, suppose we are discussing about any other media other than vacuum or air. You should use the formula V equal to what? 1 by root mu r, mu 0 epsilon mu r and epsilon 0 epsilon r. So what is mu 0 mu r? It is mu. What is epsilon 0 epsilon r? Epsilon. We know that mu equal to mu 0 mu r. Epsilon equal to epsilon 0 epsilon r. So V is equal to 1 by root mu epsilon. So all these equations are important. See, once again I am writing what are the important equations. C is equal to 1 by root mu 0 epsilon 0 or V is equal to 1 by root mu epsilon or V is equal to 1 by root mu 0 mu r into epsilon 0 epsilon r. These are the important equations here. Doubt ഉണ്ടോ? ഇത് എടുത്തിട്ടുണ്ട്, എനിക്കറിയാം. I do remember that. But you have to note it down because in this chapter also these relations are important. നോട്ട് ചെയ്യണം കേട്ടോ, കാരണം ഈ ചാപ്റ്ററിൽ അത് വരുന്നുണ്ട്. Next, when an electromagnetic wave propagates, when an electromagnetic wave propagates, electric field and magnetic field, electric field and magnetic field are perpendicular to each other, perpendicular to each other, and also perpendicular to the direction of propagation, and perpendicular to the direction of propagation. Electric field and magnetic field are perpendicular to each other and also to the direction of propagation. If electric field is along x-axis, magnetic field along y-axis, then propagation along z-axis. They are mutually perpendicular. So if electric field is along y-axis, magnetic field is along x-axis, then propagation along z-axis. Now, if electric field is along z-axis, magnetic field is along y-axis, then propagation will be along x-axis. Now, if electric field is along y-axis and propagation is along z-axis, then magnetic field is along z-axis, then propagation will be what along x-axis. They are mutually perpendicular. See, electric field and magnetic field won't come in the same direction, or electric field and direction of propagation won't come in the same direction. They are mutually perpendicular. Then electromagnetic waves are transverse in nature, They are what? Transverse in nature. What is meant by transverse wave? Transverse wave. In a transverse wave, wave propagation, particles of the medium vibrate in a direction perpendicular to its propagation. Perpendicular to its propagation. In a direction perpendicular to its propagation. That is the speciality of transverse wave. Particles of the medium vibrate in a direction perpendicular to the direction of propagation, and electromagnetic waves are transverse in nature. Electromagnetic waves are transverse in nature. There are another type of waves that you know, longitudinal. Sound waves are what? Longitudinal. Sound waves are what? Longitudinal. But electromagnetic waves are what? Transverse. Please note it down. Please note down fast. Done? Yeah. So electromagnetic waves are what? Transverse in nature. So that topic is done. Now, electromagnetic waves exert pressure called radiation pressure. Its value is radiation pressure value 7 into 10 raised to minus 6 Newton per meter square. See, these values you have to by heart. How we are getting that this value that is not given in the textbook? Simply you have to by heart. Then next point, electromagnetic waves carry momentum. If U is the energy transferred in time t, then the momentum P would be P equal to U by C. Here, momentum will be small. Since speed of light comes in denominator. Momentum will be very small. That is understood from the question equation, right? Because since speed of light comes in denominator, momentum will be what? Very small. Now, next, how electromagnetic waves are produced? That is the next question. Remember, see, time varying electric fields produce time varying magnetic fields which will in turn produce time varying electric fields. This will again produce time varying magnetic fields. And it goes on like that. And together it will produce what? Produce electromagnetic waves. Together it will produce electromagnetic waves. So remember, time varying electric fields will produce time varying magnetic fields. That will produce what? Time varying electric field. Again, that will produce what? Time varying magnetic field. And together there will be what? Electromagnetic waves. Or you can say that electromagnetic waves are produced by either accelerating charges, either accelerating charges or oscillating charges, or oscillating charges. Electromagnetic waves are produced by either accelerating charges or by oscillating, either by accelerating charges or by oscillating charges. Remember, charges at rest, that is stationary charges, charges at rest and charges moving at constant speed, and charges moving at constant speed cannot produce electromagnetic waves. Cannot produce electromagnetic waves. Cannot produce electromagnetic waves. Charges at rest and charges moving at a constant speed cannot produce what? Electromagnetic waves. So how electromagnetic waves are produced? Either by accelerating charges or by what? Oscillating charges. Charges at rest or charges moving at constant speed cannot produce what? Electromagnetic waves. I hope you are clear. മക്കളെ മനസ്സിലായോ? ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്താ? കഴിഞ്ഞാ നോട്ട് ചെയ്താ? Done. So can a stationary charge produce electromagnetic wave? No. Electromagnetic waves are produced either by accelerating charges or by oscillating charges. Done. All of you done? Akash done? കഴിഞ്ഞ എല്ലാവരും നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? Next, Ampere's circuital law. Ampere's circuital law. What is Ampere's circuital law? Line integral of magnetic field around a closed path is equal to mu 0 times the total current enclosed by the path. The total current enclosed by the path. Line integral of magnetic field around a closed path is equal to what? Mu 0 times the total current enclosed by the path. See, this is a long straight current carrying conductor. I am considering a closed path surrounding the current carrying conductor. The magnetic field inside that closed path is equal to what? Mu 0 times the total current. We have seen this Ampere's circuital law. Any doubt in the Ampere's circuital law? ഒരു കണ്ടക്ടറിൽ കൂടെ കറണ്ട് പോകുമ്പോൾ അതിന് ചുറ്റും മാഗ്നറ്റിക് ഫീൽഡ് ഉണ്ട്. ആ ചുറ്റുമുള്ള മാഗ്നറ്റിക് ഫീൽഡ് ആണ് എന്ത്? ഇന്റഗ്രൽ ഓവർ എൽ ബി വെക്ടർ ഡോട്ട് ഡി എൽ വെക്ടർ. അത് എന്തിന് തുല്യമാണ്? mu 0 ടൈംസ് ദ ടോട്ടൽ കറണ്ടിന് തുല്യമാണ്. ശ്രദ്ധിക്കുക, next I am going to prove Ampere's circuital law wrong. Consider charging of a capacitor. Charging of a capacitor. Say capacitor. There is a cell and there is a switch. When the switch is closed, there will be current charge flow or current flow. So I am considering closed path C1 just outside capacitor plate and closed path C2 just inside capacitor plate. C1 closed path outside capacitor plate, C2 closed path inside capacitor plate. Applying Ampere's circuital law, ACL stands for Ampere's circuital law, to closed path C1. Closed path C1. So integral C1 B vector dot DL vector is equal to what? Mu 0 times I. This is the current I. Now applying Ampere's circuital law to closed path C2. In C2 closed path again, integral C2 B vector dot DL vector is equal to what? Mu 0 times the current, but between the capacitor plates there is no current flow according to ampere. ആംബിയറിന്റെ ബുദ്ധി അനുസരിച്ച് കപ്പാസിറ്റർ പ്ലേറ്റിന്റെ ഇടയിൽ കൂടെ കറണ്ട് പോണില്ല. അതുകൊണ്ട് mu 0 times 0. അപ്പൊ ഇന്റഗ്രൽ C2 B വെക്ടർ ഡോട്ട് DL വെക്ടർ is equal to what? 0. This is equation 1, equation 2. But closed path C1 and C2 are very close to each other, so that their magnetic field should be what? C1 and C2 are close to each other, so their magnetic field will be equal. Because why magnetic field is equal? Because they are very close to each other. If two closed paths are equal, the magnetic field enclosed by them will be what? Almost equal. I can show that with the diagram. Suppose there is a bar magnet and magnetic lines of ours are there. Remember here, suppose this is C1 closed path and this is C2 closed path. Since these two closed paths are very close to each other, the magnetic field enclosed by them will be almost equal, isn't it? Magnetic field enclosed by them is what? Almost equal, since they are close to equal path, since they are close to each other. So that their magnetic field will be equal. That is, in equation 1 and 2, left hand sides are equal. But RHS not equal. Why right hand side is not equal? Why? One equation we have mu 0 I and another equation we have what? 0. So there is some inconsistency, means സ്ഥിരത ഇല്ലായ്മ, inconsistency related to Ampere's circuital law. There is some inconsistency related to Ampere's circuital law, which was proved by James Clerk Maxwell. So who proved Ampere's circuital law wrong? James Clerk Maxwell. Maxwell proved Ampere's circuital law wrong. By introducing displacement current. By introducing what? Displacement current. By introducing displacement current. Now you can expect a question, define displacement current. Displacement current is that current which comes into play in vacuum or dielectric when electric field varies with the time. Displacement current is that current which comes into play where vacuum or dielectric when electric field varies with the time. The equation for displacement current ID is equal to epsilon 0 d phi by dt. See, according to latest syllabus, only displacement current needed to study. You don't have to know how you got displacement current, how to derive displacement current. These things are not required. So, according to latest syllabus, only this section. Who modified ambient circuit law? Maxwell. By introducing displacement current. What is displacement current? It is that current which comes into play in vacuum or dielectric when electric field varies with the time. And the equation for displacement current, I suffix d is equal to epsilon 0 d phi by dt. What is d phi by dt? d phi by dt is what? It is what? Rate of change of electric flux. Rate of change of electric flux. d phi by dt is the rate of change of electric flux. d phi by dt is the rate of change of electric flux. Okay, please note down this. All of you know the ambient circuit law, right? Those who have joined late, please note down ambient circuit law because it is very important. എല്ലാവരും നോട്ട് ചെയ്തിട്ടുള്ളതല്ലേ ആംബിയന്റ് സർക്യൂട്ട് അല്ലോ. നെക്സ്റ്റ് പേജ് നമ്മൾ ആംബിയന്റ് സർക്യൂട്ട് ലോ റോങ് ആണ് പ്രൂവ് ചെയ്യുക. വി ആർ പ്രൂവിങ് ദാറ്റ് ആംബിയന്റ് സർക്യൂട്ട് ലോ റോങ് ബൈ ഇൻട്രൊഡ്യൂസിങ് ദ കോൺസെപ്റ്റ് ഓഫ് ഡിസ്പ്ലേസ്മെന്റ് കറന്റ്. ആദ്യം പറയാം, ഒരു കപ്പാസിറ്റർ ചാർജ് ചെയ്യണ കേസ് എടുത്തു, രണ്ട് ക്ലോസ്ഡ് പാത്ത് എടുത്തു, ഒരെണ്ണം ഔട്ട്സൈഡ് കപ്പാസിറ്റർ പ്ലേറ്റും ഒരെണ്ണം ഇൻസൈഡ് കപ്പാസിറ്റർ പ്ലേറ്റും. എന്നിട്ട് ആംബിയന്റ് സർക്യൂട്ട് ലോ അപ്ലൈ ചെയ്തു. അപ്പൊ ഫസ്റ്റ് കേസിൽ ഇന്റർവൽ C1 ബി വെക്ടർ ഡോട്ട് ഡി എൽ വെക്ടർ എന്താ μ0 I ആണ്. സെക്കൻഡ് കേസിൽ ഇന്റർവൽ C2 ബി വെക്ടർ ഡോട്ട് ഡി എൽ വെക്ടർ എന്താ, ഈ C2ൽ അവിടെ കറണ്ട് ഫ്ലോ ചെയ്യുന്നില്ല, കാരണം വയർ ഇല്ല, അപ്പൊ കറണ്ട് ഇല്ല, അപ്പൊ ഈസ് ഈക്വൽ ടു 0 ആണ്. പക്ഷെ C1 C2 രണ്ട് ക്ലോസ്ഡ് പാത്ത് തൊട്ടടുത്ത് കിടക്കുന്ന ക്ലോസ്ഡ് പാത്ത് ആയതുകൊണ്ട് രണ്ടിന്റെയും മാഗ്നറ്റിക് ഫീൽഡ് സെയിം ആ. അപ്പൊ ഇക്വേഷൻ 1ന്റെ ഇക്വേഷൻ 2ന്റെയും ലെഫ്റ്റ് ഹാൻഡ് സൈഡ് സെയിം ആ, പക്ഷെ റൈറ്റ് ഹാൻഡ് സൈഡ് സെയിം അല്ല. റൈറ്റ് ഹാൻഡ് സൈഡ് സെയിം അല്ല. അതിന്റെ അർത്ഥം there is some inconsistency what in ambient circuit law. There is some inconsistency in what ambient circuit law. ആ ഇൻകൺസിസ്റ്റൻസി ആരെ റിമൂവ് ചെയ്തേ? ജെയിംസ് ക്ലാർക്ക് മാക്സ്വെൽ ആണ്. എങ്ങനെയാ റിമൂവ് ചെയ്തേ? ബൈ ഇൻട്രൊഡ്യൂസിങ് ദ കോൺസെപ്റ്റ് ഓഫ് ഡിസ്പ്ലേസ്മെന്റ് കറന്റ്. എന്താണ് ഡിസ്പ്ലേസ്മെന്റ് കറന്റ്? ഇറ്റ് ഈസ് ദാറ്റ് കറന്റ് വിച്ച് കംസ് ഇൻ ടു പ്ലേ വാക്വം ഓർ ഡൈഇലക്ട്രിക്. എപ്പോ? വെൻ ഇലക്ട്രിക് ഫീൽഡ് ടൈം അനുസരിച്ച് വേരി ചെയ്യുമ്പോൾ വാക്വത്തിലോ ഡൈഇലക്ട്രിക്കിലോ വരുന്ന കറണ്ട് ആണ് എന്ത്? ഡിസ്പ്ലേസ്മെന്റ് കറന്റ്. എന്താണ് അതിന്റെ ഇക്വേഷൻ? I suffix d. That suffix d indicates എന്താ? ഡിസ്പ്ലേസ്മെന്റ് കറന്റ് ആണ്. എന്താ അതിന്റെ ഇക്വേഷൻ? epsilon 0 d phi by dt. Sir, according to Gauss's law in magnetism, B vector dot dl vector across C1 is 0 ആകില്ല. അല്ല, Gauss's law എന്താ പറയണേ? The total magnet plus through a closed surface enclosing a bar magnet അല്ലേ? ഇവിടെ ബാർ മാഗ്നറ്റ് ഇല്ലല്ലോ. ഒരു ബാർ മാഗ്നറ്റ് ആവുമ്പോഴല്ലേ അത് 0 ആവുക. അല്ലെങ്കിൽ പിന്നെ മാഗ്നറ്റിക് ഫീൽഡേ ഉണ്ടാവില്ലല്ലോ എവിടെ ക്ലോസ്ഡ് പാത്ത് എടുത്താലും. നവീൻ, എന്നിട്ട് നമ്മൾ മാഗ്നറ്റിക് മോണോപോൾസ് ഡു നോട്ട് എക്സിസ്റ്റ് എന്നല്ലേ പറഞ്ഞേ? Sir, due to displacement current, will there be current inside the capacitor? Yes, that is our point. There will be current flow inside the capacitor. That current flow is called the displacement current. That we will see. In the next page, I will be explaining that. See, once again, I am telling you, this detailed analysis is not required according to latest syllabus. According to latest syllabus, they are telling you to study by heart definition of displacement current and by heart the equation for displacement current. How we are getting that equation, that is not in the syllabus. But I have explained it, but you don't have to study that. Because without explanation, I can't simply give this definition. ഞാനിത് എക്സ്പ്ലെയിൻ ചെയ്യാണ്ട് നേരെ ഡെഫിനിഷൻ പറഞ്ഞാൽ കുട്ടികൾക്ക് ഒന്നും മനസ്സിലാവില്ല. അതുകൊണ്ടാണ് ഞാനിത് എക്സ്പ്ലെയിൻ ചെയ്തേക്കണേ. പക്ഷെ ആ എക്സ്പ്ലനേഷന്റെ ആവശ്യമില്ല. സിലബസ് പറയണത് ജസ്റ്റ് ഡെഫിനിഷൻ ബൈ ഹാർട്ട് ചെയ്യാനാണ്. അത് തന്നെയാണ് ഞാൻ നേരത്തെ മൊമെന്റത്തിന്റെ ഇക്വേഷൻ പറഞ്ഞപ്പോഴും റേഡിയേഷൻ പ്രഷറിന്റെ വാല്യൂ ബൈ ഹാർട്ട് ചെയ്യാനാണ് പറയണേ. അതൊന്നും എങ്ങനെ കിട്ടി എന്ന് പഠിക്കാൻ പറയുന്നില്ല. നോട്ട് ചെയ്യട്ടോ. നോട്ട് ചെയ്യട്ടോ. നോട്ട് ചെയ്താ? നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? All of you noted? All of you finish? Agash, Naveen, Vismaya, done? Is it done? Let's continue. Again, consider charging of a capacitor. Consider charging of a capacitor. See, it's a capacitor. There is a cell, there is a switch. Here, current is flowing or charge is flowing. Here, the electric field between capacitor plate varies. According to Gauss's law, what is that? Phi is equal to integral over S E vector dot ds vector is equal to 1 by epsilon 0 times q. So phi is equal to 1 by epsilon 0 times q. As electric flux varies, with the time. d phi by dt, I am differentiating. d phi by dt is equal to what? d by dt of q by epsilon naught. Isn't it? d phi by dt is equal to d by dt of q by epsilon naught. That is equal to d phi by dt is equal to epsilon naught is a constant. 1 by epsilon naught is a constant. So 1 by epsilon naught dq by dt. What is dq by dt? Displacement current. Displacement current. dq by dt is displacement current. So d phi by dt is equal to 1 by epsilon naught I suffix d. Displacement current is equal to what? Epsilon 0 d phi by dt. This is the equation for displacement current. I hope you got. dq by dt is rate of charge flow. That is a current. That current is what? Displacement current. So we came to know even between the plates of a capacitor, a current flows called displacement current. So capacitor plate in current flow change. So total current I is equal to what? Total current I is equal to conduction current I suffix C plus displacement current I suffix D. That is the total current. Total current I is equal to what? I conduction current plus displacement current. So what is ambient circuit law? Integral over L B vector dot dl vector is equal to mu 0 I. That I, instead of I can write what? Integral over L B vector dot dl vector is equal to mu 0 into IC plus ID. So integral over L B vector dot dl vector is equal to mu 0 IC plus mu 0 ID. That is integral over L B vector dot dl vector is equal to mu 0 IC plus mu 0. Instead of ID, I can write what? Mu 0 epsilon 0 d5 by dt. Integral over L B vector dot dl vector is equal to mu 0 IC plus mu 0 epsilon 0 d5 by dt. And the last equation, or these equations are not known as Ampere-Maxwell law. Why Ampere-Maxwell law? Because conduction current is Ampere's contribution, but displacement current is the contribution of Maxwell. So, since this equation contains both conduction current and displacement current, together they are known as what? Ampere-Maxwell law. Any doubt? Together they are called Ampere-Maxwell law. Any doubt? Doubt now. മക്കളെ മനസ്സിലായോ? ഡൗട്ട് ഉണ്ടോ? Please note it down. നോട്ട് ചെയ്ത എല്ലാവരും? നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? ക്ലിയർ ആണ്? നോട്ട് ചെയ്ത് കഴിഞ്ഞാൽ എല്ലാവരും? ലാസ്റ്റ് ലോ ആണ് എന്ത്? ആംബിയർ മാക്സ്വെൽ ലോ. ഇന്റർ ഓവർ എൽ ബി വെക്ടർ ഡോട്ട് ഡി എൽ വെക്ടർ ഈക്വൽ ടു മ്യൂ 0 ഇൻറ്റു ഐ ആണ്. ഐ എന്താ? ടോട്ടൽ കറണ്ട് ആണ്. ടോട്ടൽ കറണ്ട് എന്താ? കണ്ടക്ഷൻ കറണ്ട് പ്ലസ് ഡിസ്പ്ലേസ്മെന്റ് കറണ്ട് ആണ്. അപ്പൊ ഇന്റർ ഓവർ എൽ ബി വെക്ടർ ഡോട്ട് ഡി എൽ വെക്ടർ ഈക്വൽ ടു മ്യൂ 0 ഐ സി പ്ലസ് മ്യൂ 0 ഐ ഡി. നോട്ട് ചെയ്ത് കഴിഞ്ഞാൽ എല്ലാവരും? Next topic is Maxwell's equations. Maxwell's equations. First Maxwell equation, integral over S E vector dot ds vector is equal to 1 by epsilon 0 times q, which is Gauss's law in magnetism. See, although this equation is Gauss's law in Gauss's law in electrostatics, still this equation is called what? Maxwell's equation. Second, integral over S B vector integral over S B vector dot ds vector is equal to 0. This is what? Gauss's law in magnetism. This order is also important. You cannot write it in your own orders. Have to follow this order. This is the second Maxwell equation, which is Gauss's law in magnetism. Now third Maxwell equation, integral over L E vector dot ds vector is equal to minus d phi b by dt. This is Faraday's law, and the minus sign Lenz's law. And the fourth Maxwell equation, integral over L B vector dot dl vector is equal to mu 0 into IC plus epsilon 0 d phi by dt. What is this equation? It is actually this Ampere Maxwell law. Still it is called what? Fourth Maxwell equation. Remember, when electromagnetic wave propagates, all these equations should be satisfied. Electromagnetic wave propagate ചെയ്യുന്നതെല്ലാം ഈ 4 ഇക്വേഷനെ സാറ്റിസ്ഫൈ ചെയ്തിട്ടായിരിക്കണം. ഇത് ബൈ ഹാർട്ട് ചെയ്യാനുള്ള 4 ഇക്വേഷൻ ആട്ടോ. നമുക്കറിയാം, ബൈ ഹാർട്ട് അല്ല, നമുക്കറിയാം ഗോസസ് ലോ ഇൻ ഇലക്ട്രോസ്റ്റാറ്റിക്സ്, ഗോസസ് ലോ ഇൻ മാഗ്നറ്റിസം, ഫാരഡേസ് ലോ. നോട്ട് ചെയ്യട്ടോ. ഫാരഡേസ് ലോ NCERT E.dl ആണ്. ഞാൻ എന്ത് ചെയ്തേ? DL ആണ്. ശരിയാ, DL ആണ്. താങ്ക് യു ഫോർ കറക്റ്റിംഗ് ദാറ്റ്. It should be E.dl. DL തന്നെയാണ് കേട്ടോ, ഞാൻ എഴുതി തെറ്റിയത്. E.dl. താങ്ക് യു ആകാശ്, താങ്ക് യു. ഇത് കഴിഞ്ഞാ? All of you noted? All the 4 equations noted? Next, when an electromagnetic wave propagates, amplitudes of electric field and magnetic field are related by C is equal to E0 by B0. What is C? C is equal to speed of light. E0 amplitude of electric field. B0 amplitude of magnetic field. B0 amplitude of magnetic field. B0 amplitude of magnetic field. C is speed of light. Equation for electric field in electromagnetic wave propagation. Equation of electric field. Ex is equal to E0 sin ky minus omega t. What is this Ex? Ex indicate that electric field is, this equation is very important. The equations which is written and which I am going to write is a very important for CBSE, Kerala board, KEAM, JEE, NEET, all the exams. Ex electric field of E0 electric field. Ex indicates electric field is along x direction. E0 amplitude of electric field. K propagation vector. propagation vector. K is equal to 2 pi by lambda. K is equal to 2 pi by lambda. K propagation vector. Omega angular velocity. Omega is equal to 2 pi nu. Lambda wavelength. Nu frequency. Lambda wavelength. Nu frequency. Velocity V is equal to omega by K. Velocity of the wave is equal to omega by K. K is propagation vector, angular. Okay. Now next, Ex can be written as Ex is equal to E0 sine. Instead of K, I can write 2 pi by lambda into Y minus 2 pi nu into T. This is also correct. This is also correct. Now, variable after K indicates direction of propagation. So here variable after K is Y. That means what? The wave propagates along Y direction. That means wave propagates along Y direction. Electric field equation Newton per Coulomb or V bar M. This you can see, these are the unit of electric field, which is either Newton per Coulomb or volt per meter. Variable after K indicates the direction of propagation. Here, this electromagnetic wave travel in which direction? This electromagnetic wave travel in positive Y direction. If variable after K indicates direction of propagation, here variable after K is Y, so it is propagates in Y direction. If there is negative inside, then it is what? Positive Y direction. Any doubt? മക്കളുടെ ഡൗട്ട് ഉണ്ടോ? ഡൗട്ട് ഉണ്ടോ? ഇത് ഇമ്പോർട്ടൻ്റ് ആണ് കേട്ടോ, ഇത് ഭയങ്കര ഇമ്പോർട്ടൻ്റ് ആണ് മക്കളെ. Now, ഇതിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള മാഗ്നറ്റിക് ഫീൽഡ് ഇക്വേഷൻ. See, magnetic field equation will be what? See, electric field is along x direction, direction of propagation is along y direction, so magnetic field has to be what? Z direction, because during electromagnetic wave propagation, electric field, magnetic field, direction of propagation all are what? Mutually perpendicular. So Bz is equal to B0 sine ky minus omega t. Now you can see a into T. What is that T? That T is Tesla, unit of magnetic field. That T is what? Tesla. So Bz is equal to B0 sine. Instead of K, I can write what? 2 pi by lambda into Y minus 2 pi nu into T. So Bz is equal to B0 sine. If you take 2 pi outside, Y by lambda minus 2 pi into T. Again into Tesla, not into Tesla, unit Tesla. Any doubts? So, sorry, 2 pi is taken outside. So, no T. Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്യോ? ഡൗട്ട് ഉണ്ടോ? ലിസൺ, എല്ലാവരും ഇത് നന്നായി പഠിച്ചോളൂ. കാരണം നെക്സ്റ്റ് ഫ്രൈഡേ ക്ലാസ്സിൽ ഞാൻ ഇതിന്റെ പ്രോബ്ലംസ് ആണ് ചെയ്യാട്ടോ. നെക്സ്റ്റ് ഫ്രൈഡേ ക്ലാസ്സിൽ ഈ ഇക്വേഷനെ ബേസ് ചെയ്തിട്ടുള്ള പ്രോബ്ലംസ് ആണ് ചെയ്യുക. No, if the electromagnetic wave is traveling in y direction, why it is written Ex? Ex is the electric field. I told you, Devika, when electromagnetic wave propagates, electric field, magnetic field and direction of propagation all are mutually perpendicular. So electromagnetic wave is traveling in y direction means what? Electric field can be seen either in x or z. Here magnetic field is along z direction, so electric field has to be along x direction. Then only it will become mutually perpendicular. അത് മനസ്സിലായോ? ഡൗട്ട് ഉണ്ടോ? എന്നാ മാത്രമേ അത് മ്യൂച്വലി പെർപെൻഡിക്കുലർ ആവുള്ളൂ. നോട്ട് ചെയ്യട്ടോ, നോട്ട് ചെയ്യ, എല്ലാവരും നോട്ട് ചെയ്യും. നോട്ട് ചെയ്ത എല്ലാവരും? So all of you, thank you. Next ക്ലാസ്സിലേക്ക് എല്ലാവരും please by heart this formula. Next class we will be doing problems. Okay, so thank you all. Thank you.